Okay, we have the present value of compound interest problems video here. And our success criteria for the day are to be able to calculate the present value of an investment given the future value, the interest rate, and the number of years invested. And these are previous concerns so that you can draw a timeline for an investment, determine the values of I and N for various compounding periods is key to success, and solving problems involving comparing future value with present value. Also, I need to be able to communicate my work and understanding in a mathematical format in a form understandable to others. Our independent practice will be page 476, questions 4 to 7, and 9 and 11. All right, so as a warm-up, I'd actually like to think about this example and draw a timeline and complete as much as possible. So complete as much as possible. So hit pause and do that now. Okay, so hopefully you were able to come up with a timeline. So a very strong line there. Nicholas has opened an investment savings account. The interest rate is 2.75% per annum compounded quarterly. He wants the amount to be $5,000 in 5 years, or sorry, in 8 years. So what principal should he invest now? So I know that N, because it's quarterly, is going to be 4 times 8 or 32. I know that I is going to be 2.75% per annum, but that needs to be divided by 4 and expressed as a decimal. So I'll grab my calculator and work that out. So 2.75 as a decimal percent is 0.0275. And when I divide by 4, I get the very small decimal value, 0.006875. Now, P, we're not sure. We don't know because it says what should the principal be. So this is my unknown this time. And the amount that I should have in the future is actually $5,000. So that's a little bit weird. Now, if I'm going to drive my timeline in, then I'm going to put 0. And at the far end, I have 8 years. And way down here is where I'm supposed to have the $5,000. Again, this is fairly unusual. And each year I'm investing 4 times. So every quarter. So 1, 2, 3, 4. I'm getting compound interest earned. Okay, and so that continues for quite some time, and I can see where the number 32 comes from. Well, if I had known the present value or the principal that was invested, then I would have been able to calculate the A. So I would have used the formula A equals P times 1 plus I to the N. Well, those are still the same unknowns as before, so I'm actually going to substitute in as before and see what I can get. So I have $5,000 is supposed to be whatever the principal amount was times 1 plus I, which in this case is 0.006875, and that's all raised to the power of 32. And I'm going to pull up my graphing calculator here. Okay, so pulling up my graphing calculator, I can enter the part in the brackets, 1 plus 0.006875, and that value needs to be raised to the power of 32. So I can get that value. So I can extend this then to have the output in the brackets of 1.2451, etc. So I know that 5,000 is equal to some principal rate times 1.2451, and let's just check that one more time, 39. Well, now this is just a linear equation. If I divide by the value in the bracket, then I can get P by itself. So I will. 1.245139 and divide by the same over here. and I had rounded that. So using my calculator, I'm actually going to leave that value into my calculator and just type 5,000 times, I want, actually it's the reciprocal value, so I want my original answer to the, to the reciprocal value, and we get 4,015.62 rounded is the amount that must have been invested. Therefore, 4,015.62 must have been invested originally. So really this isn't any different, except for this time we aren't given the principal, but we're still using the same formula as before. Okay, so this is just our general compound interest formula. So something to make note of is when we're thinking about the problem, because he was investing for the future, the amount that he invests now ought to be less than the future value because it's hopefully growing. So again, I'll double check. I had that he invested the value of $4,015, and that is less than the amount that's desired of $5,000. So if I put it in here, it does make sense that 4,015 has grown all the way after 8 years to $8,000. So switching to the next slide, we see we can actually just use the generic formula A equals P times the bracket of 1 plus I all to the n, or I could isolate for P by dividing through by the bracket. So I would have A 1 plus I all to the n is equal to P, and we know that since x to the negative 2 could be represented as 1 over x squared, we could also represent this formula then as P equals A over, A times 1 plus I to the negative n. So any of those versions are absolutely acceptable for calculating the present value of an original investment. Okay, finally, example 2. Tony has $3,000 in the bank, and he intends to buy a laptop and a printer and invest the remainder for 2 years, compounding monthly and at an annual rate of 1.75%. He wants to have $2,000 in his account 2 years from now, so how much can he spend on the laptop and the printer? Okay, there's a lot of information in here, so I'm going to get my timeline set up. So I know this is all about 2 years, and I know that there's a value in the original time frame. He intends to buy, and it says he wants to have $2,000 2 years from now. So again, this needs to have a value of $2,000. We see right now he currently has $3,000, but he's going to take out some of it, so he's going to take out an unknown amount. Okay, and then the remainder is what becomes invested, and let's see, it's monthly, so there's 1 year, and then I need about 12 ticks in here for it to earn interest. So clearly, I can already estimate that he must have taken quite a lot of money. So they estimate the laptop and the printer is over $1,000. I know that because he's not going to invest only $2,000. So this is going to be less than $2,000 because eventually it grows to $2,000. Okay, so we haven't learned about annuities yet, but just in this context, he's investing money and he is not adding any more to it. He's just simply earning the interest. So I know I'm going to be using the formula amount is equal to principal plus I to the power of n. And I will need to then identify the I and the n. So I know that I'm investing for 2 years and it's monthly, so I'm going to multiply by 12, so this is 24. And I know that I'm earning 1.75%. So that's 0.0175 divided by 12 as my I value. This time, since it's such a small value, I think I'm going to just put it in the brackets like that. Okay, now the last thing I have to figure out is, am I filling out the P or am I filling out the A? Well, again, I know the only value I know about money is after 2 years. So that's the amount is in 2,000 years. Or sorry, the amount is $2,000. The principal is the thing that I don't know. So I'm going to rearrange my formula once I have my values in and solve for principal. Okay, so let's see. So we have $2,000 is equal to the principal that I'm not sure of, 1 plus bracket 0.0175 divided by 12, and this whole thing is to the power of 24 because it's for 2 years. And looking at this, I could evaluate the value of the bracket that's multiplying by P, so I think I will do that now with my calculator. All the $2,000 in the P stays the same. So I'll put that value and put my calculator. Okay, so I need to have bracket 1 plus, I need another bracket for this fraction, decimal 0.0175 divided by 12. Close that bracket to deal with the I part, and then I also need to close the bracket again, and that full bracket is raised to the power of 24. So I hit enter, and so that tells me then that my multiplier of the principal is 1.03559. 1.03559 approximately. So that's the value that I'll divide both sides by, and then I should be able to determine what principal amount was left that he invested, and then I should be able to figure out then how much he must have spent on his computer and his laptop. So 2,000 times the answer reciprocal of the multiplying factor. So I must have invested $1,900.31. Sorry, $1,931.26. And approximately. Okay, going back to the question to make sure I've answered it properly, how much can he spend on the laptop and the printer? So I haven't actually figured that out yet. I figured out how much he invested. So 3,000 subtract 1931.26 is the printer and laptop cost. So we have $1,068.74 is what I'm allowed to spend on my technology costs. And that way I will still be able to have $2,000 in the bank after 2 years. Okay, those are your two examples of working to calculate the present value or the original value of a compounded interest investment when you know the future value. So your textbook is your practice, and please do your Edmodo quiz as well. Good luck.